Okay, so this is part 3 of my PowerPoint on energy flow through ecosystems, and this is about energy pyramids primarily. Now, when we talk about ecology, we can use visual representations to show the relative amounts of energy or matter in different trophic levels with things called ecological pyramids. Now, sometimes you might have a pyramid of biomass, which is showing like the relative amounts of actual like living things, biomass. It could be pyramids of numbers, so if you were to count the organisms. But I'm going to focus this video on energy pyramids to show the relative amounts of energy in each trophic level. So let's go ahead and talk about energy pyramids, right? So here on my left, you can see that I have a pyramid showing different trophic levels. The bottom part of this pyramid is going to represent our primary producers. And then we have our herbivores as the second part of this pyramid, which is our primary consumers. Then we have our secondary consumers, followed by our tertiary consumers. Now, it's important to remember that these organisms, they need energy to carry out life's processes. And we think about, well, what do we need energy for? Right? We need energy for movement, for reproduction, for growth, cellular respiration. And so we have a constant input of food, which is energy, and then we use a lot of that though. If you think about all the food you have consumed in your life, it's not all still part of you, right? A lot of your carbohydrates you've actually exhaled because in our mitochondria, we break apart our carbohydrates to produce ATP for our cells. And in the process of breaking apart our carbohydrates to make energy for us, we actually will exhale the waste product of carbon dioxide. And so it actually leaves us and enters back into the atmosphere. So anyway, when we talk about most of the energy consumed by heterotrophs, it's used in life. And a lot of it is actually going to be released as heat. When you exercise, if you go for a run, for example, you generate, as your mitochondria are using your blood sugar, your glucose, to make ATP to power your muscles, those chemical reactions actually are going to release a lot of heat. So as organisms carry out their life, a lot of the energy is used and then converted into heat, which is not a usable form of energy. And so very little of the food we actually take in actually becomes incorporated into our body tissues and stored in the body of the organism. So if we take that into account, we see that actually only about 10% of the energy available in one trophic level is actually transferred to the trophic level above it. So here, if we have 100% like energy starting with our autotrophs, that means only roughly 10% of the energy in that trophic level is transferred to the herbivores and like stored in the tissues and the bodies of the herbivores. Now, as we go up the trophic levels, again, 90% of the energy is used or released as heat, leaving only 1% available for that next trophic level. Now, earlier in my previous video on food webs, I talked about how there's a limit to the number of trophic levels in a food web or food chain. Oftentimes, we kind of stop at that tertiary consumer level. Very rarely is there enough energy at the base of the food web to support quaternary consumers or a fifth trophic level. Simply, there's just not a lot of energy available to those top predators. Think about all the times you've been outside. You mostly see plants. And then you see herbivores. I live by a park, so I see rabbits and seed-eating birds and squirrels all the time. And then if you think about how often you see secondary or tertiary consumers, that's going to be way less often. Of course, I guess it depends on if you live in the city or if you live where you have more open spaces. I think that will also fluctuate. But generally, I camp and hike a lot, and I've seen very few bears or bobcats or mountain lions in my life, right? Because there's less energy to support a large population of those tertiary consumers. So if we do a little math problem here, if we think about, well, how much energy is available to each trophic level here. So if we start out with 50,000 joules of energy, in the herbivores, we're going to have 5,000 joules of energy. followed by 500, and then 50, and then 5 at that fifth trophic level of quaternary consumers. So you can see how hypothetically you could say trophic levels would go on forever, but energy is going to be like a limiting factor. It's going to limit the number of trophic levels that can exist in a food chain or a food web. So we really kind of call this the rule of 10. And so is it possible to have unlimited trophic levels in a food web or ecosystem? No, because the energy will eventually decrease so much that it can't support large predators. All right. That is my video on energy pyramids. If you're a teacher and you're interested in this PowerPoint, you can check the link below. I have it for sale, and I hope it was helpful for you. Great job.